Hello, hello. Can you hear me? Okay, hello everyone. Glad to see you all here today. And my name is Valery Markov. I'm from team Argonauts, based in St. Petersburg. And today I'd like to tell you about our experience migrating Pushko service from Redis to RabbitMQ. Let's start with a quick intro to Pushko service. Pushko, as the name suggests, pushes messages to client HTTP endpoint or SMPP or some email server. And message types include delivery reports, and for OTT messengers, so it's also deleted, seen, all that stuff, you know. And another type is MO. Traffic type, which is mobile originated, which is a really important type. That's when mobile user sends some messages to business and they go through InfoBip platform. So that's very important because that assumes some interactive scenario, this kind of situation. And we also have some generic raw type for forwarding some unformatted key value data to clients. So that's about Pushko service. It has some useful features which are used in various use case scenarios, such as you see here. And some stats about Pushko. It's installed in 16 data centers from 2 to 5 nodes per DC. And the maximum load is obviously in FR5. It's up to 10,000 messages per second. That's the load we have. And another notable fact is that because MO traffic is so important, it should be processed as a priority. It has different retention rules and stuff, so we have separate instances for MO traffic and separate traffic flow. So we had this Redis plus HaloDB solution for storing messages. And Redis was set up in high availability setup with one master, one replica, and Redis Sentinel's instances were monitoring master and replica and doing the failover. In case of any troubles, our Redis typical max memory was 7 gigabytes, but we had to have from 20 to 24 gigabytes on virtual machine with Redis because Redis actually needs triple memory. I'll get back to this later. And HaloDB as an embedded Java database was used as an extension storage when data just couldn't fit per cheat into Redis, and of course as a backup storage. Okay, this solution had some downsides. For example, HaloDB embedded storage was node local, and for communicating with Redis, we had some in-memory queues in order to process the messages in order, and also retry logic was in memory, and also we couldn't keep all of our data in Redis because that we would need too much memory because Redis actually needs triple memory of its data set because of the replication process working in background and the persistence to disk process working in background. They triple the memory requirement. So we've also heard from other teams that in case of huge data sets in Redis, they had some problems with reliability with failover and replication, so we didn't want to have that. Hot adding memory, if you need to increase data set, is complicated. In some cases, not possible. I recommend this article from our colleague Milan, one Redis anti-pattern, where he makes the conclusion that Redis is not a good fit for a service like Pushko. Short-lived state, high throughput. Yeah. We have considered some alternatives. We have considered Redis cluster, but Redis cluster we also need to get rid of in-memory processing somehow. We didn't know how. And also in Redis cluster, you have sharded data set, so you need to account for that. And Kafka was looked like a potential fit, but it also has some sharded dataset restrictions, and Kafka infrastructure wasn't in all data centers that we need Pushko in. At the same time, RabbitMQ had some advantages, such as you see here, it had some features we like and found useful, and in performance-wise, SSD disk storage helps. You can easily add disk storage and so on. Okay, so we have implemented this new solution using RabbitMQ. As Pushko service becomes a publisher of data and a consumer of data. So we used consumer acknowledgements and publisher confirms to guarantee delivery. That's a must. We had to choose between classic queue mirroring and quorum queues, which are newer algorithm for replication. We saw some important downsides that we considered of quorum queues, so we have chosen classic queues for replication. And we decided to keep HoloDB as a node local persistence storage, and as a backup in case RabbitMQ becomes unavailable, and that saved us quite a few times, so that was a good decision. Some stats on our RabbitMQ clusters, same 16 data centers, odd number of nodes in cluster 3 or 5, replication factor 3, and as for memory, we have from 8 to 20 gigabytes per node for RabbitMQ, and that's much higher than we expected, because everything is persisted on disk. Why we need to have 20 gigabytes for RabbitMQ, but I'll get to this, get back to this a bit later. Retry logic, we have, in case of unsuccessful sending of messages to client, it will be retried with the increasing interval like this until it is delivered or expired. DLRs are valid for 2 days and MO messages for 10 days. Recently, we have implemented custom retry logic, which can be configured per cheat, per client, so it can be pretty flexible, like number of retries, the interval formula, and stuff like that. So it can be flexible. So we used this RabbitMQ feature, message time to leave, TTL, to implement retry logic, and it looked pretty easy for us to implement. So in normal message flow, all messages, they get to so-called main queue, which is per cheat and service type. And in case of unsuccessful request to client, the message gets to a special retry queue, which is created per particular retry interval. And it is set for this particular message TTL, like 60 seconds in this case. After 60 seconds, message forwarded automatically to that letter retry queue and consumed by Pushko for resending to client. In case it's still not successful, the interval will be increased, and then will be another retry queue with like 2 minutes interval, and the same schema repeats. So this has a potential problem of increasing number of retry queues until it is expired. So yeah, we saw some of that problem, but partially. Some stats about our queues in RabbitMQ. In FR5, you can see that total queue size can grow up to several millions. In some pretty bad cases, some crazy traffic, which which is not consumed, it can grow to like 10 million and more than that. But usually it's more like this. And number of queues, as you can see in FR5, is pretty high. That's like 7,000 queues. That's a lot. And it is a known fact that RabbitMQ doesn't really handle well that large queue size and that high queue number. So unfortunate for us. We had some queues housekeeping logic to try to keep it small and the number of queues small, but still we are having like 7,000 queues in FR5. Of course, we did stress test the solution. First, we tested RabbitMQ as a message broker in isolation. We saw good numbers, performance numbers, so it was fine. Then we implemented the solution and was stress testing end-to-end RabbitMQ and Pushko using JMeter tool to send requests to Pushko. As a request train, like an imitation of a client endpoint, we didn't find a suitable public request bin that we can use, like Bceptor and some others. They were not suitable for us. So we implemented a Pushko request bin service, custom, with all the features we need for stress testing. So feel free to fork this repository if you need configurable request bin. How close I/O is to production-like environment? Of course, it has less resources. So we just couldn't replicate the load we would have on FR5 or Mumbai or FR4. So we were fighting to get the resources on I/O just to make a stress test, and we promised to give them back as soon as possible. But yeah, it's a problem. We couldn't test. Ideally, we would test in production, but as we had live traffic on all DCs, we couldn't do that, so we had to do with I/O. But newer DCs like US3, they are doing, as you might know, they are doing stress tests before going live. So that could be a good opportunity for testing some new solutions in production without live traffic. We try to imitate production traffic in terms of like you have a lot of thousands of cheats, each with a very varying workload, like message rate or queue size and stuff like this. So try to imitate production traffic, obviously. Chaos testing we didn't do actually, but we've read after that about a very good blockade tool for testing network partition scenarios. So we have encountered a few issues related to RabbitMQ in our stress testing, and even what's worse after on deploying in production. So let's go over some of those and see what was the problem and its solution. Okay, first problem. As soon as we started stress testing, we saw very high memory consumption with not so much loads, and of course, eventually we realized that default queues type is non-lazy, so just normal queue, but it's not suitable for large queue size, like in millions of messages. So okay, so this information it's too detailed. So solution: use lazy queues. And that don't require much memory. Okay, next problem: high memory consumption with lazy queues. So after we switched to lazy queues, we saw occasional high memory consumption and even high disk consumption. So that looked like a memory leak. But we just couldn't pinpoint we just couldn't reproduce it reliably, unfortunately. So we are still wondering. So what's the solution? Is it issue with memory allocator or Docker or Erlang VM or RabbitMQ? We have plans to upgrade to Erlang 24, which is the latest one, very recent one, which is supposed to fix some performance issues. but it's incompatible with our current version, so need some upgrade plan. Next issue, in case of network partition, like nodes lose connection to each other, they start to evolve in parallel because they cannot communicate. And after network partition is over, it's all fine. Actually, this partition state continues to go on because the default strategy is ignore, needs manual resolution. RabbitMQ admin need to go and see like which nodes to restart, which nodes to keep and stuff like that. There are some automatic strategies like auto heal or pause minority, and they're pretty good, both of them pretty good. I don't know why default is ignore, and choosing between auto-heal and pause minority, it's about CAP theorem. Auto-heal is emphasizes availability. It keeps nodes up for as long as possible. And pause minority emphasizes consistency. So it pauses the minority nodes. So partitions don't evolve in parallel. So it will be just one winning partition. We have auto-heal currently, but actually we realized that consistency is more important for us, so we need to switch to pause minority. Actually, we saw other teams using auto-heal or pause minority, I guess, depending on their use case. Another problem, okay, another strange default configuration. Queue master is created where the client connection is, but that could potentially create a very uneven distribution of queue masters, and okay, it's easy, just use min masters this configuration and it's fine, and even RabbitMQ devs say you need to spread them evenly. I don't know, the default is client local. Still, because nodes, VMs will be migrated, VMs will fail, some will be upgraded and stuff like this. The distribution will shift to some of the nodes, and that's pretty bad. That's uneven load. You can use this rebalance command to rebalance, but it's also very strange. It takes forever to finish, and it can make queues unresponsive. Still outstanding problem is load per cheat can vary wildly depending on the queue size, message rate, and it can change all of a sudden. So just balancing masters of the queues doesn't really balance load in our case. So we need to kind of account for this and implement this more fine-tuned rebalancing. Okay, surprise. Node deletes all of its data on before syncing with cluster. So after, if you restart a RabbitMQ node, it will delete all of its data because it assumes that the data is obsolete, so it needs to synchronize. Okay, so that's probably a correct assumption, correct logic, but in case you have problems in your cluster and you need to learn about node startup logic, like it will be started in the vice versa order, and there's also some difference between node shutdown, normal, and node failure modes. So in one case, we had this problem with cluster. We weren't sure what was the order, and in the end, it was also with the network partition state. And so in the end, we used the force boot option to start at least some of the nodes. And in the end, they tried to synchronize with each other, and on startup deleted all of their data. So it caused total data loss. Okay, so just keep track of node failure order if possible. Just be careful, yeah. And especially with force boot option, it can be unpredictable. There's okay, when restarting, migrating nodes, queue synchronization is a blocking operation, surprise. So of course, in case of large queues, so we had to create a script that, let's say we need to migrate or upgrade or restart some node. We use this script to very slowly move away masters of all the largest queues, because otherwise they would be unresponsive on the queue restart. So that's another thing. Publisher connections should be distributed over the cluster evenly in order to ensure best performance. Okay, lessons learned. All of this is pretty obvious, but it needs reiterating. Okay, I can tell you from my heart that it's very important. So read the freaking manual. RabbitMQ documentation is pretty good. It's pretty accessible, so read it. It's interesting in some cases. Try to follow best practices, obviously, and try to use the experience of other InfoBip teams. So we tried to use it, we consulted with other teams, but our use case was unfortunately a little bit different from the others. And lessons from stress testing, try to push the limit, even if you have to do it on I/O. Try to, I don't know, request as much resources as possible. Try to nag sysinfra team, or I don't know, is it Team Guardians? Okay, try to get a lot of resources on I/O, at least temporary. Identify bottlenecks. In our testing, we saw that we are not stress testing RabbitMQ integration, but we are stress testing Pushko logic, which is not related to RabbitMQ. So just keep an eye on that, and don't be afraid to reconsider options. So now, after we've learned all of this, we probably need to evaluate all of this behavior in the case of quorum queues. Because maybe they have some downsides that we saw, but maybe we can live with them, but get rid of those issues. Okay, so in conclusion, we can say that RabbitMQ is not the best fit for our use case, for Pushko's use case, but still we got the advantage that we are handling high load in data safe fashion, data safe manner. And it can be scaled to handle more. So that's our conclusion. Thank you very much. Thanks for your attention. So any questions, maybe, if you have them?
Have you had to deal with RabbitMQ duplicating messages, like you take the same message off twice? Has that been something in your experience, something that's happened or not?
Duplicated delivery?
Yes.
Yeah. So in case of course, like in case of a network partition or node becomes unavailable, messages will be redelivered, and they have this flag which marks them as being redelivered. But in our use case, actually it turned out not to be, it doesn't matter that much for our use case. So okay, we'll send a notification twice. It's probably already accounted for. So yeah, it will happen, and it happens, but we don't care in Pushko.
Okay. And one more question. Do you find that the persistence on RabbitMQ is slowing it down too much? I know when I've looked into it in the past, persistence is one of the things they said made it too slow.
You mean when using durable queues?
Yes.
But for us, there was no choice. We had to use durable queues. So, and actually we didn't compare non-durable with durable, because we knew from the start that we need durable queues, and we stress tested that configuration. Well, it looks it's good enough for us at the moment, and can be scaled. Yeah.
What rate are you testing it at?
Sorry?
What rate? How fast did you test your messages? How many per second?
Yeah, so as I said, so usually, of course, it's not like 10 Ks per second. Usually it's more like, I think in FR5, probably probably like from 1 to 2,000 per second. So that's kind of load. It's average. But of course, you know that how bulks of messages come all of a sudden, and it's like bulk of 3 million messages because it was the campaign for 3 million people. Yeah. So you have to have some some leeway. Yeah. Anybody else? I was actually going to ask you a question because I was still not sure on this why we didn't choose Kafka, because actually I think now because Kafka is a simpler tool. No. So I'm just not sure. So if anybody can say versus RabbitMQ versus Kafka, if anybody can say if it's what's the comparison? Anybody knows this tricky question? So I guess that's the question for Team Kafka. So I'll tell you what their answer will be, but later. So thank you very much for your attention. Yeah, I guess that's it.